Welcome to all for this today's session. In today's session, we are going to solve a plain truss problem solving by using the method of joints. So let's start with a truss problem. It is being given a truss with the number of members A, B, B, C, C, D, then D, E, E, A as well as E, B. So like that, number of members is being given as totally 7. Then what are the number of joints? One, 2, 3, 4, 5. That is number of joints is 5. So totally we are having m is equal to 7 as well as 2j minus 3, 2 times joints. So 2 into 5 equal to 10 minus 3 equal to 7. So m is equal to 2j minus 3. The mathematical expression, the condition satisfies. So this is comes under a perfect truss. So we can use the method of joints to move on further. Then we will have a problem now we can take. Now first we can find either reaction at E and E, A and E. Otherwise we can have a possibility to find any member forces we can look on. Here it is being given as at point D. At point D you are being given a load of 8 kilonewton. Okay. Next, what about the other forces? So we have a member directly joined with the D 8 kilonewton and DC. So towards outward you can draw the diagram. Initially we can assume that everything is tensile forces. Then D to E. So DE, FDE, FDC. Okay. So this is the free body diagram. How can we find these two unknown members first? So as per the statical equilibrium equation, we can find the member forces. One is sum of all vertical forces that is equal to 0 with a sign convention, that is upward forces are taken as positive. So here we are having upward force, that means vertical forces only 8 kilonewton, and this inclined load can be resolved into a vertical load towards upward action. And this is purely horizontal, so don't take this one. So this FDC sine 60, this is minus 8. Okay, like that you can take, you will get a value as positive 9.24 kilonewtons of tensile. Then how can we find another force? FDE. For that you can use another statical equilibrium equation called sum of all horizontal forces that is equal to 0. And same here, FDE is a purely horizontal. Now I am taking towards left is positive. Sign convention is ours. We can take our source. Then FDC inclined member, so it comes towards left as FDC cos 60 as the horizontal component. So these two you can take, this minus 8 purely vertical, so don't take it as. So finally we can get FD is 4.62 kilonewton, which is negative value. So we are assuming it's a tensile force, but comes as negative, so it should be a compressive force. That means the direction should be in the reverse order. So the tensile becomes compressive force. The next one is, after finding these DE and DC, we can move on to another joint. We have to choose where the joint has number of unknown forces. Here we have CD and CB as well as CE are there. So CD we know, but CB and CE is the two unknown forces. So free body diagram accordingly can draw. Okay, so you can use sum of all vertical forces that is equal to 0 with the sign convention. Upward forces is positive. So here upward forces means this FCB will not come. If in two inclined forces will come to picture for vertical component of sine theta, because the angles are being associated directly with the horizontal axis. So FCE sine 60, this 9.24 sine 60 only. Okay, which one is positive and which one is negative, that is the matter. Here this goes towards upward action and this goes towards downward action. So this is negative, this is positive. Okay, so now we are getting the value of FCE as positive value, and here we are getting only negative value, directly can get it. So this is compressive force, and this is towards right is positive I'm taking. So we have FCB, and these two inclined force will be resolved into horizontal component of cos 60. Here also cos 60, and sign convention you can take, this is goes towards right, towards right is positive. It is also goes towards right is positive. You can get FCB as a 9.24 positive value, which is a tensile force. Then we can move on to another joint B. Here the possibility 1, 2, and 3. Three members is directly associated, but FBC already found. So these two unknown values are there. That is FBA and FBE. Okay. So these two forces use the statical equilibrium equations, and we can get two values of two members directly. Okay. So FBE is that is equal to FBA. Both are 9.24 kilonewton in the negative value. So it is both are compulsive forces. And finally, we can move on to the another joint E. If you are taking AB, AE, two unknown forces are there, and we cannot take directly. Why? Because an unknown support reaction is not there. So we can take this one and this one. Okay. So now I'm going to move for the support reaction. Here E, that is vertical support reaction, and EC as well as EB and ED, EA. So totally 1, 2, 3 and 4, 5. But out of 5, 3 are known values. Only 2 unknowns. So you can use these two statical equilibrium equation to find the values. So support reaction at Y, that is E is equal to 16 kilonewton, and FEA unknown force is equal to 4.62, which is the compulsive one. Okay. So finally we are getting all the values, all the member forces here with natural forces. Positive will come as tensile, negative forces will come as negative. So that's all from this class. We have solved a simple plane truss problem by using the method of joints. Finally, we have to summarize of the number of members with respect to the member force values and nature of forces. Like that, we can conclude. So that's all in this class. We will have another topic with the different topic in the next class. Thank you all.